Okay, let's dive into this. Welcome to today's explainer, where we are going to demystify exactly how an AWS continuous integration pipeline actually works. And we aren't just going to sit here and talk about theory today. No, we are going to walk through the architecture of building a fully automated, cloud-based factory for a Python Flask application. We're going to take raw code and transform it into a ready-to-deploy container, all using managed AWS services. So I want to pose a question to you to kick things off. What actually happens the very second a developer hits commit? In the olden days, that action kicked off a totally chaotic sequence of manual pain points. Developers had to manually pull code, run local builds, and literally cross their fingers that they didn't accidentally expose hard-coded credentials. It was incredibly slow and honestly pretty insecure. Well, today, we're going to look at an automated, highly secure AWS solution that completely eliminates all of that friction. Here's our roadmap for how we're going to build this out. We'll start by mapping out the CI factory floor. Then we'll source our raw code, meet our heavy lifter AWS CodeBuild, figure out how to secure our keys, and finally bring it all together with the ultimate orchestrator, AWS CodePipeline. All right, let's get right into it with section 1, the CI factory floor. So what does continuous integration, or CI, actually mean in the exact context of our project today? Well, it boils down to 3 specific things. First, automatically checking out our application code the moment it changes. Second, building a Docker image from that code. And third, securely pushing that finished image up to a container registry, like Docker Hub. That's it. That is the finished product we're aiming for. But before we can zoom into the individual machines that make this happen, we need our raw materials. Which brings us to section 2, sourcing the raw code. Everything has to start in our source code repository, which in this case is GitHub. We've got our fundamental building blocks here. There's our basic Python Flask application code. We've got a requirements.txt file, which just tells our environment to install Flask. We have a Docker file, which pulls a Python base image, installs those requirements, and exposes the port we need. And then, crucially, we have a buildspec.yaml file. You can really think of this file as the explicit instruction manual for our automated factory. And what's fantastic here is that, even if you're building a massively complex enterprise application, this basic raw material structure, it remains essentially the exact same. Now let's move on to section 3 and meet the execution environment, the heavy lifter, AWS CodeBuild. Before we get into the weeds, I really want to draw a sharp contrast to clear up a super common architectural confusion. People mix up CodePipeline and CodeBuild all the time. Think of AWS CodePipeline as the orchestrator or the factory manager. It just watches for changes and flips the switch to start the assembly line. AWS CodeBuild, on the other hand, is the execution environment. It's the worker on the floor, doing the actual heavy lifting. In our setup, CodeBuild is going to spin up a managed Ubuntu virtual machine just to execute our instructions. So what exactly are those instructions living inside our buildspec.yaml? Well, there are 4 distinct phases our CodeBuild worker is going to execute. First up, the install phase, where we set up our Python 3.11 runtime environment. Second, the pre-build phase, where we run pip install to get our Flask dependencies ready to go. Third, the actual build phase, where we execute the Docker build command. And finally, the post-build phase, where we securely log into Docker Hub and push up our newly minted image. This file is literally the step-by-step logic of our continuous integration. Now, the crucial point here is this configuration checkpoint. When you're setting up AWS CodeBuild to build Docker images, you have to intentionally check a box to enable privileged mode. If you forget this step, and trust me, people do, your entire build will fail because the environment just won't have the elevated permissions it needs to connect to the Docker daemon. It's a tiny configuration detail, but it's literally the difference between a successful pipeline and a broken one. But wait, this brings up a massive tension point. Think about that post-build phase. We need to push our image to Docker Hub, which obviously requires a username and a password. So how in the world do we safely use our Docker Hub passwords without hard-coding them directly into our buildspec.yaml file? I mean, if anyone gets access to our code repository, we absolutely do not want them seeing our plain text passwords. No way. That leads us right into section 4, securing the keys. To resolve this password problem, we're going to use another AWS service called Systems Manager Parameter Store, or usually just called SSM Parameter Store. Think of SSM as the factory's highly secure encrypted safe. Instead of pasting our sensitive information, like our registry URL, our Docker username, and our passwords straight into our code, we lock them tightly inside this vault. And hey, a quick pro tip on this. When it comes to your secrets, naming conventions are absolutely crucial. When you're just building one single app, sure, you can name your secrets whatever you want. But when you start scaling your architecture up to tens or hundreds of microservices, complete chaos can ensue. Adopting a strict standard like app name, underscore, credential type, underscore, specific key. For example, my app, underscore, Docker credentials, underscore, password. Keeps your secrets perfectly organized and easily identifiable. It's a highly practical habit that will save you massive headaches down the road. So once our secrets are safely stashed in the vault, we just map them directly into our CodeBuild environment variables. Our build spec YAML simply references the variable names like Docker registry username. The actual values themselves, they stay entirely hidden. When CodeBuild goes to run the Docker login command, we use a neat little trick where we just echo the password and pipe it directly into the login command. It securely authenticates without the password ever appearing in plain text in our files or, importantly, in our build logs. However, there is one catch here. Just like a human user needs an ID badge to open a locked door, an AWS service needs an identity to interact with another service. This is where identity and access management, or IAM, roles come into play. We have to grant our CodeBuild service role explicit policy permissions to access the system's manager parameter store. If CodeBuild doesn't have the proper clearance to open that SSM vault, the build is going to fail right then and there.
All right, home stretch. Section 5, the ultimate orchestrator, AWS CodePipeline.
AWS CodePipeline is the manager that runs this entire automated show. We basically configure CodePipeline to establish a secure OAuth connection directly to our raw materials supplier, which is GitHub. We tell CodePipeline to constantly watch a specific branch, usually the main branch, and just wait. It sits there, patiently observing, waiting for new code to arrive. And this brilliantly illustrates our final, glorious, fully automated flow from start to finish. Step 1, a developer makes a change and commits code to GitHub. Step 2, CodePipeline instantly detects that change and triggers the process. Step 3, it taps CodeBuild on the shoulder, which provisions a fresh Ubuntu environment, reads the buildspec.yaml, fetches the secure keys from the SSM vault, and executes the build. Step 4, the fully authenticated, newly built Docker image is pushed right to Docker Hub, ready to be used. And that brings us to my absolute favorite part, this incredibly satisfying number. 1. It now takes exactly one single manual action, just a simple git commit by a developer, to reliably, consistently, and securely trigger this entire factory line. There are no manual Docker commands, there's no passing passwords around in Slack, just one single action to create a production-ready container. Which leaves us with one final exciting question to ponder. The code is integrated, the image is successfully built, and it's sitting there safely in the Docker registry, but what happens next? Well, while our continuous integration pipeline is now absolutely perfect, taking that waiting container and actually deploying it out into the wild for your users, also known as continuous delivery, is the thrilling next chapter. Thank you so much for joining me on this explainer, and keep building.